In under 24 hours, the third known interstellar visitor will disappear. Not explode. Not fade. It will slip behind the Sun and vanish from every Earth telescope. Astronomers call this a solar conjunction. I call it the universe closing a curtain. For the first time, an interstellar object will hit its peak energy while completely out of sight. What happens in that silence? No one knows. Tonight, while two green comets streak across our skies and draw attention, a third will slip behind the Sun. Stay with me to the end as we unpack what 3I Atlas is about to do. What we learn may change how you view interstellar visitors. Less than a day from now, something unprecedented occurs. A visitor from another star system, designated 3I Atlas, will align behind the Sun and leave every ground telescope blind. This is not an ordinary event you miss if you blink. This is different. No comet or interstellar body we've tracked has reached peak speed and energy while also becoming invisible. Telescopes pointed near the Sun risk damage. You do not point expensive optics into the solar glare. So we do not look. For weeks, while Atlas moves through the most intense phase of its path, we will be blind. Atlas was found on July 1, 2025 by the Asteroid Terrestrial Impact Last Alert System Survey, the network that hunts rocks heading our way. From the first orbit plot, astronomers knew something odd was happening. Its path is hyperbolic. It arrived from outside our solar system. That fact made Atlas the third confirmed interstellar object. The first, 1I/Oumuamua, passed through in 2017. It had odd shape and motion and sparked intense debate about origin. The second, 2I/Borisov in 2019, acted more like a typical comet. Both remained visible during closest approach. We could watch them, record spectra, image jets, track fragments. Atlas will not give us that luxury. It reaches perihelion, closest approach to the Sun, on October 29, 2025, roughly 203 million kilometers, or about 1.36 astronomical units. That is exactly when speed, solar heating, and tidal stress peak. And all of it happens while Atlas hides. A Harvard astronomer who raised questions about Oumuamua has pointed out the timing. Conjunction on October 21st. Perihelion 8 days later. Those events sit back to back, not separated by months. Coincidence or design? I will not leap to aliens. Atlas most likely is a natural object, ice and rock ejected from a distant system millions of years ago. Comet formation is violent. Ejection into interstellar space is rare but not impossible. As detection improves, we should expect more such visitors. The existence of Atlas is not shocking. The timing is. Picture a play. The lead walks off stage as the climax begins. The most important scene plays while the curtain hides the stage. That is our problem. Perihelion is when comets become most active. They fragment. They flare. Jets erupt. Surfaces change. Their motion shifts from outgassing forces acting like tiny thrusters. All this will happen while we cannot observe. We have some instruments that might help. Solar spacecraft like SOHO and the Parker Solar Probe sit closer to the Sun than Earth and might detect scattered light or disturbances in the solar wind as Atlas passes. Stereo satellites could catch tail changes. These will be scraps of information compared with the spectra and high-resolution images ground telescopes would normally supply. We will lose spectroscopy that reads composition. We will lose imaging that shows jets or fragments. We will lose precise astrometry that refines orbit. The most important phase will unfold behind a glare. Perihelion is where the drama lies. Solar heating vaporizes ices, forming comas and tails. Internal pressure can drive sudden outbursts. Structural weaknesses cause breakups. Comets have surprised us. They have brightened, split, and shifted course due to asymmetric outgassing. All of this could happen to Atlas while we are blind. In the next 24 hours, observatories will make a final push. Last spectra, final images, closing astrometry. Every photon is precious. Amateur astronomers with backyard gear will try too. A network of hobbyists often contributes meaningful astrometric and photometric data. Right now, the global astronomical community is racing the clock to collect closing snapshots. Those data will have to carry us through weeks of silence. And while we wait, a question sits with us. What if something happens behind that curtain? What if Atlas does something unexpected in the one period when no human eye can watch? When it returns weeks from now, will it be the same object we last saw? Or will we face fragments, altered motion, unexplained brightening? We will be left with pieces and forced to reconstruct the lost act. The silence window is literal. For several weeks, Atlas will be unobservable from Earth. We will lose capabilities we assume as given. Spectroscopy goes dark. Spectroscopy is how we read chemical fingerprints. Light from a coma splits into wavelengths and reveals water, carbon compounds, sodium, and more. Without spectra, composition is unknown. If Atlas starts expelling unusual gases while hidden, we will not know. Precise astrometry will vanish. Each observation refines a trajectory. If the object changes speed or direction during the blind phase, preconjunction predictions will not match postconjunction reality. We will have to reverse engineer motion from incomplete clues. Imaging disappears. We will not see fragmentation in real time. Comet nuclei fracture. Chunks peel off. Sometimes the breakup is catastrophic. If Atlas fragments at perihelion, we will only witness aftermath, a debris field where a single nucleus used to be. We will guess at timing and mechanism. Perihelion brings peak velocity, thermal stress peaks, tidal stretching peaks. All the forces that produce drama reach maximum strength. Missing this is not a small loss. It is missing the heart of the show. Historically, other comets have passed behind the Sun. This has happened before. None of those were interstellar objects reaching perihelion during conjunction. Those cases involved bodies we tracked for years with predictable behavior. Atlas is different. We've known about it for less than 4 months. We are still learning. Now the best part of its behavior will happen unseen. The practical fallout is real. Observatories will reallocate time. Telescope hours are scarce and scheduled. Why spend time on a target you cannot see? Other science will take priority. When Atlas reappears, there may be a lag before large facilities point at it again. Amateur observers and smaller institutions may be first to catch post-conjunction light. Those first days are crucial. Delays cost detail. There is also a psychological effect. Scientists prefer continuous observation. Gaps breed uncertainty. For an object already unusual, uncertainty is uncomfortable. You want more data, not less. The silence window denies you that. Now address the thought people hesitate to voice. What if something deliberate occurs during conjunction? I am not claiming it will. I am not claiming artificial origin. But the question exists. If someone designed an interstellar probe and wished to act unobserved, perihelion during conjunction offers maximum energy and near total invisibility from Earth. A probe could release smaller instruments or adjust trajectory while no wide-angle Earth telescope watches. Natural explanations remain far more likely: outgassing, fragmentation, thermal cracking. Still, the timing creates a blank page where speculation grows. So the waiting game begins. Atlas goes dark. Weeks pass. Solar observatories might catch hints. Ground telescopes look elsewhere. Behind the Sun, hidden in glare and distance, Atlas continues. It moves fast, heats up, maybe changes, maybe not. We will not know until it returns. Now look at the path. Interstellar objects enter from random angles. Space is three-dimensional. You expect random arrivals. Atlas did not follow that expectation. It came in nearly aligned with the ecliptic plane, tilted roughly 5 degrees from Earth's orbital plane. Most objects in our solar system lie near that plane because they formed from the same disk. Interstellar visitors have no reason to respect our plane. So why is Atlas so politely aligned? Perhaps coincidence. Statistics allow outliers. But when coincidences stack, neat arrival angle, conjunction timing and perihelion 8 days apart, a trajectory that takes it near several planets while hidden, the picture becomes harder to dismiss as pure luck. Astronomers have tried to backtrace Atlas's path to find an origin. One runs orbital solutions backward through time to search for a parent star. For some interstellar objects, this yields plausible candidate regions. For Atlas, no clear parent star appears. The backtrace points generically towards Sagittarius, near the galactic center, but nothing specific emerges. The object seems to have arrived from far and scrambled. Observers also note velocity oddities. Collected astrometry since July hints at slight non-gravitational components. Those deviations might be outgassing. When ice vaporizes on one side, jets nudge the nucleus. We see this regularly. For Atlas, the deviations are subtle and the data baseline is short. Natural outgassing remains the leading explanation, but uncertainty persists. Perihelion distance is about 1.35639 Australian dollars, around 203 million kilometers. That's outside Earth's orbit but inside Mars. It will reach perihelion on October 29, 2025 at 11 hours 34 minutes and 35 seconds terrestrial time. That precision is striking. Orbits can be computed with high accuracy when data are sufficient. But all precision breaks if the object behaves unpredictably during conjunction. If Atlas undergoes unexpected activity, perihelion timing or distance might shift slightly, and we will only learn after the fact. Some speculative work suggests galactic structure might create gravitational corridors. These are not tunnels but regions where combined gravity guides object motion along preferred paths. If such corridors exist, they may channel interstellar objects from certain directions. The Sagittarius corridor hypothesis is fringe but under study. If real, it might explain repeated arrivals from similar directions. Be candid, the natural explanation is simplest. Atlas is a comet ejected from its system long ago. Galactic dynamics scramble paths. Coincidences happen. The ecliptic alignment could be chance. Velocity anomalies might be ordinary outgassing. These positions are defensible. But another explanation exists. If Atlas were engineered, entering along the ecliptic makes sense. Planets orbit there. Perihelion during conjunction provides energy and privacy. Passing near planets while unseen would be useful for gathering data or deploying probes. This is not proof. It is an observation that an engineered route and the observed path share features. The question lingers. The anomaly deserves scrutiny. The answer requires evidence. While Atlas prepares to vanish, the sky is not quiet. Around October 20th, two bright comets, C/2025 A6 Lemmon and C/2025 R2 SWAN, are visible in the northern hemisphere. If you know where to look and have dark skies, you might see green fuzz near sunset. Comet Lemmon, discovered January 3, 2025 by the Mount Lemmon survey in Arizona, brightens as it approaches Earth. On October 21st, as Atlas enters conjunction, Lemmon reaches peri-Earth at about 0 Australian dollars and 60 cents, roughly 90 million kilometers. Under dark skies, it should be visible to the unaided eye as a faint green smudge. The color comes from diatomic carbon glowing in sunlight. Look northwest after sunset. Binoculars help. Comet SWAN, discovered September 10, 2025 by instruments aboard SOHO, specializes in hydrogen detection. Around October 21st, it passes at roughly 40 to 50 million kilometers. Its visibility is less certain. Predictions suggest possible naked eye brightness, but comets are unpredictable. As of mid-October, it remains faint and best seen with binoculars or a small scope. Position is low in the southwest after sunset. The coincidence is poetic. Two solar system comets shine for observers while a third, interstellar visitor, disappears. The Orionid meteor shower peaks near October 20th to 21st. If you watch the sky, you might see meteors streak from Orion's direction. The sky that week is busy: Lemmon northwest, SWAN southwest, Orionid meteors east, and Atlas moving unseen behind the sun. The visible comets create a visual narrative. They are accessible. Anyone with binoculars and dark skies can join the experience. Atlas is invisible to all but instruments. Most people won't know it exists. The spectacle draws eyes away while the hidden visitor continues its secret passage. Maybe this is coincidence. Maybe not. If you step outside to watch the green comets, remember that another traveler from beyond is slipping out of view. The countdown accelerates. Hours now, not days. This is the decision window. Observatories capable of seeing Atlas are racing to collect closing spectra, images, and astrometry. Telescope time is expensive and scheduled months ahead. Directors' discretionary time exists for urgent events. Atlas qualifies. Amateur contributions are significant. A decent backyard telescope, a CCD, and some software allow useful photometry and astrometry. Citizen science matters here. Yet rumors swirl. Some whisper that spectroscopy of Atlas shows odd composition, withheld from public release pending peer review. Claims mention lower water content or unusual elemental ratios. These are unconfirmed. Preliminary results often fail scrutiny. Science moves slowly for a reason. Publication requires careful validation. Until results pass peer review, rumors remain noise. Why would composition matter? Composition reveals origin. Comets from our outer solar system show certain chemistries. Interstellar comets reflect their home conditions. If Atlas's spectrum departs from known populations, it hints at unfamiliar formation environments. In speculative frames, anomalous spectra fuel alternative interpretations. But caution. Unverified claims are unreliable. Science checks and rechecks. Until publication, speculation entertains but does not prove. If you have access to a telescope, Atlas remains faint, magnitude around 13 to 14. You need an aperture of at least 8 inches and accurate ephemerides from the minor planet center. Long exposures might capture final preconjunction images. Participation matters, even if scientific impact is modest. Being part of the observation feels meaningful. Atmosphere shifts among observers. Anticipation mixes with dread. Soon the object goes into a tunnel. You see it enter and wait for emergence. Will it be the same? Will it be altered? The stakes feel huge because interstellar visitors are rare. Losing the most interesting phase feels like a cosmic missed opportunity. Perihelion, 8 days after conjunction, makes the scenario cinematic. Maximum speed, maximum heating, maximum stress, all while invisible. If you were scripting a thriller, you might not do better. Now consider the Sagittarius corridor hypothesis. Some point to a pattern around Sagittarius. Oumuamua's backtrace loosely linked to the galactic plane. The 1977 WOW signal arrived from Sagittarius. Atlas aligns roughly toward that region. Is this meaningful or a product of pattern seeking? The hypothesis suggests some galactic directions act like routes. Gravity from stars, clouds, and dark matter might shape paths where objects drift with less resistance. These gravitational corridors would be subtle but persistent. If true, multiple interstellar objects might arrive from similar skies. Advanced civilizations might also exploit such corridors. Selection bias matters. Sagittarius covers a large patch. It holds the galactic center, so we point instruments there more often. We find events where we look. Correlation is not causation. The corridor idea is intriguing but unproven. If advanced travelers use corridors, their routes would look like natural ones. An engineered probe might blend into the background motion. This makes detection harder. We need evidence before leaping to conclusions. Now the data suppression debate. Some allege observations of unusual objects get delayed or withheld. Is there truth? Science ideally shares data publicly. The Minor Planet Center aggregates astrometry. Sky surveys release images. Yet proprietary periods exist. Teams analyzing data often receive exclusive access for months. This protects scientific investment. It is not suppression in a conspiratorial sense. National security adds complexity. Some observations touch sensitive missions or defense assets. In those contexts, governments may withhold information. How often this happens is unclear. For Atlas, rumors of held spectroscopic data are unverified. Caution explains delay. Preliminary signals that look strange may evaporate on closer analysis. Historic errors, cold fusion, faster-than-light neutrinos, teach caution. Premature announcements damage credibility. Delays invite suspicion. If Atlas shows anomalous signatures, researchers might wait to confirm before public release. Peer review takes time. By the time a paper appears, the conjunction will be over and the public may already imagine cover-ups. In practice, astronomy is global and distributed. Amateur observers publish images. Independent teams collaborate. Suppressing data across that network proves difficult. Citizen scientists act as checks. Independent observers can post findings without institutional gatekeeping. If something strange appears, amateurs will report it. That distributed attention reduces the chance of long-term suppression. Yet, interpretation still matters. Data might be public, but narratives vary. Unexplained aerial phenomena controversies show how delayed acknowledgement erodes trust. Transparency reduces conspiratorial thinking. In short, most likely there is no grand conspiracy. Data delays likely reflect scientific caution and normal proprietary practices. But the conjunction fuels suspicion. The object goes dark and unknowns grow. When Atlas returns, comparing independent observations with institutional releases will be crucial. Next, the role of a provocative voice in this story. A prominent Harvard astronomer known for pushing unconventional ideas has focused attention on Atlas. He argued earlier that Oumuamua deserved scrutiny beyond natural explanations. He noted its small non-gravitational acceleration and proposed light sail as one hypothesis. His stance stirred debate. Many colleagues rejected the artificial hypothesis as unlikely. Extraordinary claims require extraordinary evidence. He replied that excluding possibilities without investigation also risks missing truths. On Atlas he highlights the timing. Conjunction on October 21st and perihelion on October 29th, 8 days apart. He notes ecliptic alignment and a path that moves near planets while hidden. He does not claim proof of artificial origin. He urges scrutiny. Critics warn against sensationalism. They emphasize prior probability. Interstellar probes would require huge resources and rare civilizations. The reputational risk of public alien claims is real. He founded an initiative to search for technological artifacts and advocates focused, instrumented monitoring of unusual candidates. His approach asks for investigation without premature verdicts. Whether you agree or not, his attention raised public interest. If there's even a small chance Atlas is unusual beyond natural processes, the blind window becomes critical. Energy matters. Orbital mechanics gives a clear reason perihelion is powerful. A burn at high orbital speed yields greater change in energy. Kinetic energy scales with velocity squared. A small impulse at high speed alters trajectory more efficiently than the same impulse at low speed. For a hypothetical probe, perihelion is the most efficient moment for a maneuver. Combine perihelion with conjunction and you get a time of high energy and low observability. If someone wanted to perform actions unseen, this would be ideal. Natural processes offer alternative explanations. Outgassing at perihelion produces jets and momentum changes. Thermal stress and tidal forces break comets apart. At $1.36, solar flux is lower than inner solar system but still significant. If Atlas had solar collectors, perihelion gives maximum power. but no evidence for engineered systems exists. If Atlas performed a deliberate burn at perihelion, it could alter exit trajectory or release smaller probes. Observational signatures would include sudden brightening, tail changes, fragmentation, or astrometric deviations. Observation is required to distinguish natural from engineered causes. Observation is denied during conjunction. So inference will rely on before and after comparisons. Stack all unusual factors and ask, coincidence or choreography? Start with ecliptic alignment. Then conjunction and perihelion timing. Add direction toward Sagittarius. Add planetary proximity during invisibility. Add subtle velocity anomalies. Multiply low probabilities and the stacked odds start to strain plausibility. But humans naturally find patterns in randomness. Clustering illusions and confirmation bias make us overweight coincidences. The naturalist view, Atlas is a rare but natural cluster of unusual but explainable factors. The choreography view, stacked coincidences suggest intent. Both approaches have value. Science progresses by considering possibilities while demanding evidence. Next, communication technology changes the search. In October 2025, operational quantum communication experiments reached milestones. Satellite quantum entanglement experiments moved beyond labs to functional links across continents. Entanglement does not allow faster-than-light messaging, but it enables fundamentally secure channels. SETI historically focuses on radio. Radio is noisy and inefficient. Civilizations may evolve through radio to lasers to quantum networks. If so, our radio searches might miss advanced civilizations who use different modalities. An artificial probe might use directed optical links or quantum channels during perihelion to exchange data. Such signals would remain invisible to traditional radio surveys. The absence of a radio signal does not equal absence of communication. This is not wild fantasy. It is extrapolating human tech trends. If Atlas is artificial, a lack of radio emissions carries little weight. The object might connect to a network in ways we cannot detect. The conjunction window could be when it joins a channel we do not possess. AI reshapes detection. In October 2025, machine learning systems applied to archival datasets uncovered previously missed events. Algorithms found subtle signals in noisy archives. Astronomy faces data overload. Survey telescopes produce terabytes nightly. Human analysts must prioritize. Machine learning processes massive data and finds anomalies humans miss. Applied to Atlas, AI might find patterns in the preconjunction data that hint at perihelion activity. A subtle periodicity in the light curve, a faint spectral deviation, a tiny trajectory kink, these might escape human eyes but appear obvious to a trained neural network. Conversely, AI can hallucinate false patterns. Algorithmic outputs need human validation. When Atlas reemerges, AI tools will compare before and after observations. If humans see nothing obvious, AI might uncover subtle changes. AI has already improved exoplanet and gravitational wave discovery rates. For interstellar object science, AI could increase detection and interpretation power. But trust issues arise. Do we value algorithmic flags enough to follow up? Will human teams assign weight to machine detections? The success of future interstellar science depends on this balance. Also note the Sun itself is active. October 2025 lies near an intensifying solar cycle. NOAA warned of heightened coronal mass ejection risk. Solar storms complicate observations. Coronal mass ejections and solar wind disturbances add noise to instruments, disrupt satellites, and create ionospheric changes that affect radio. If a strong CME strikes near Atlas's perihelion, space weather might alter instruments meant to monitor it. Solar storms can also trigger enhanced comet activity through abrupt particle flux increases. Solar storms produce auroras for observers on Earth. They also muddy the signal environment for spacecraft like SOHO, Parker Solar Probe, and Stereo. Their sensors can suffer. A storm during Atlas's passage produces a double blackout, geometric invisibility behind the sun plus instrumental noise from space weather. Black hole studies add a useful metaphor. Observations of Sagittarius A*, our galactic center black hole, show X-ray and radio echoes. When matter falls into the black hole, flares reflect off surrounding clouds and return delayed signals. Echoes reveal structure and probe relativistic effects. Echoes are delayed information that arrives later and still carries evidence of the original event. Interstellar objects operate like echoes. They are physical records of distant events. A probe is an echo of its maker. A comet is an echo of formation processes. The WOW signal and other anomalies from the Sagittarius direction emphasize echoes in a literal and metaphorical sense. Information persists. It bounces. With the right tools, delayed signals tell a story. Turn the mirror. If someone is watching Earth, what do they see? Leakage of radio and TV, satellite swarms, atmospheric pollution. We are noisy. Voyager and Pioneer carry deliberate messages. But our broader electromagnetic output reveals a technological species in flux. An outside observer may assess our maturity and decide whether to engage. Are we ready for being observed? International protocols exist but remain informal. If a discovery arrives, chaos follows. Media, governments, religions, scientists, all respond in different directions. Transparency matters. If institutions delay release, public trust erodes. If we lack coordinated response plans, confusion will rule. Citizen science again acts as a distributed check on institutional opacity. So the question stands, if an object observes us, do we want to be judged by a planet that cannot coordinate its own data? Our response itself becomes evidence. In hours, Atlas crosses the invisible line. Our view goes dark. For several weeks, we wait. We will listen for scraps from solar probes. We will comb archives. We will run algorithms on old data. We will prepare for reconnection when Atlas returns. When it emerges, we will learn if the lost act held answers or only more questions. Tonight, if skies are clear, look for Lemmon and SWAN. Watch for Orionid meteors. And remember, behind the sun, an interstellar visitor is completing a peek in secrecy. When it reappears, we will see an echo of what happened while blind. Stay alert. Stay curious. Keep looking up. The universe is speaking. We must learn how to listen. When the silence ends, what we see will define how this story is remembered. If Atlas reappears intact, following its predicted path, brightness consistent with expectation, the natural explanation wins. It will be a confirmation of physics, a reinforcement of the ordinary. But if Atlas looks altered, fragmented, dimmer or brighter than projected, slightly off its predicted orbit, the questions return. Did we witness a normal comet evolving through solar stress, or did something occur beyond what we understand? Astronomers will move quickly when visibility returns. Every available telescope will target Atlas. Ground observatories, space probes, radar arrays, all will try to collect data simultaneously. Software will compare pre- and post-conjunction measurements to check for deviations. AI systems will run predictive models and search for anomalies. Scientists will want confirmation, a narrative that fits. If Atlas comes back looking wrong, the debate reignites. Was it natural? Was it deliberate? The discussions will be public and fierce. Some will call for restraint, others for openness. Governments might monitor conversations. News cycles will amplify speculation. The lines between science, politics, and fear will blur. Behind the noise, data will drive everything. Spectra will show whether the chemical mix changed. Astrometry will show if the trajectory shifted. Imaging will reveal structure. Each clue will matter. Because what we are dealing with, hidden for weeks behind the sun, could change how we view interstellar space, as random drift or as something organized. If it's only a comet, it will still teach us. Every interstellar object expands our understanding of planetary formation across the galaxy. We learn how matter moves between stars, how debris evolves in different environments, how systems eject their fragments into the void. Each discovery refines models of galactic chemistry and motion. Atlas will contribute to that knowledge, even if it turns out to be entirely natural. But if Atlas deviates, even slightly, the implications spread fast. If trajectory changes exceed what natural outgassing explains, we enter unknown ground. Scientists will have to model alternative forces. If composition contains compounds not expected from natural formation, we face new chemistry. If post-conjunction motion seems guided, it raises uncomfortable questions about control, about purpose. The first to notice might not be a major institution. It might be an amateur posting a faint light curve discrepancy online, or a student processing open data, or an AI flagging a correlation in archives. Discovery often begins in the quiet corners before it reaches the headlines. The public will demand answers. Space agencies will hold press briefings. Papers will appear within days, then rebuttals. Analysts will revisit all pre-conjunction data, recheck assumptions, and simulate outcomes. Every fragment of information will be reinterpreted. Did the object split naturally? Did it eject mass? Did we miscalculate solar heating? Or did something act intentionally? And if we find nothing strange, if Atlas reappears exactly as predicted, that too is important. It will close one chapter but leave the door open for the next visitor. Because there will be more. The Rubin Observatory will start detecting new interstellar travelers every year. Most will be ordinary. Some will be weird. One may be unmistakably artificial. Atlas may simply be the prelude. The silence, though temporary, changed how we think. It reminded us that not seeing is part of science. That gaps in observation hold value because they test our patience and reasoning. The lost act forces humility. We cannot watch everything. We cannot control when the universe reveals itself. We can only prepare to catch it when it does. The next phase begins with reemergence. Atlas will come out from behind the sun in late November. Faint at first, then brighter as it moves away. The first images will arrive. Comparisons will begin. Every pixel will be examined for hints. Every brightness variation will be logged. The world will wait for analysis. And while scientists study light curves, the rest of us will confront what this story means. Whether you believe Atlas is rock or machine, message or accident, it carries a mirror. It forces us to see our curiosity, our fear, our longing for connection. It exposes our tendency to fill silence with stories. If Atlas is a comet, it is a messenger of nature, a wanderer from another sun that crossed our path for a brief moment. If it's more than that, it's a messenger of intelligence, proof that the universe has already learned to travel, to explore, to send itself between stars. Either way, it speaks. And even if Atlas says nothing, even if the data are silent, we have heard something in the waiting. We have heard our own hunger to understand. We have watched our scientists, our amateurs, our instruments, all point upward together. We have remembered how to look up. Soon, the blind period will end. The sun will move, the glare will fade, telescopes will lock on, and the curtain will lift. We will see what emerges, an ordinary comet or something that redefines ordinary. Until then, keep your eyes on the horizon after sunset. The green comets Lemmon and SWAN still glow faintly, reminders of what remains visible. The Orionids still streak across the sky, fragments of Halley's long-past trail. Above those lights, the sun hides what might be the most interesting object we have ever lost sight of. Atlas is still there, racing through its unseen arc, pushed by the same physics that move every world and every fragment in the galaxy. Whether natural or not, it belongs to the same story, a universe in motion, full of travelers, full of echoes, full of things we don't yet understand. The countdown has ended. The silence continues. And somewhere beyond the glare, a visitor from another star burns unseen, carrying secrets through the heart of our sun's shadow, waiting to be seen again.